Hello everyone, welcome to AdMath with Wanshan again. Alright, we have come to the third part of motion along a straight line. So our topic today is on acceleration. Alright, okay, what is instantaneous acceleration? Instantaneous acceleration is the rate of change of velocity with respect to time. Okay, it's how the velocity changes with time. So A is equals to dv over dt. A is a differentiation of the v. Okay, so let's, for example, if in a question they given you like that, 3t squared plus 5t minus 1, you want to find A, all you have to do is differentiate this. So you get 6t plus 5. Okay, so this is your how you get the acceleration. And the unit for acceleration usually is meters per second, like this. Okay, the units for acceleration. Differentiate the v, you get the A. Alright? Okay, next. Acceleration is a vector quantity. Vector meaning it has magnitude and direction. Magnitude is the measurement and the unit is meters per second. Direction is in here, in acceleration, is not the same as displacement and velocity. In displacement and velocity, positive means movement to the right, negative means movement to the left. But here no. In acceleration, if it's a positive acceleration, it means that the particle is increasing in speed. It's getting faster and faster. So you are accelerating. Okay, like when you drive a car and you press on the oil, what happens to the car? Press on the petrol, the car moves faster, isn't it? So that's positive A. If it's negative A, it means velocity is decreasing. That means now you are pressing on the brake. When you press on the brake, what happens to the car? It's going to move slower and slower, right? So that is negative A. Okay, another word is deceleration. Okay, and then if A is equals to 0, it does not mean that the particle has stopped. Okay, it's still moving. Okay, the particle is moving with a constant velocity. Okay, velocity is at a constant speed. Alright, so that's what the magnitude of A means. Alright, number 3. When the velocity is maximum or minimum, okay, remember maximum point, minimum point, dv dt is equals to 0. And here we know that dv dt is equal to A, therefore A equals to 0. So next time in the question, if you see the magic words maximum or minimum, then you use A equals to 0 and you can solve your question. Alright, number 4, velocity is actually the integration of A, because when you want to find A, we differentiated dv over dt, right? We differentiate V, you get A. So now if you are given A and you want to find V, you are going this direction, opposite direction, so you need to integrate the A. When you integrate the A, you are going to find your V. Alright, so you can find from S, you can find V, V you can find A, and vice versa. Okay, when we integrate the A, you get your answer plus C, because this is indefinite integration, you have a C there. So now, how do you find the value of C? Okay, now depends on the question. If the particle had started from the point O, then you can sub T0, V0, so V0, T0, and you can find your C. But if the question states otherwise, let's say the particle, when it starts, the particle is at a certain V, a certain speed, so you use that value. Okay, you sub T0, V, whatever in the question, you sub here and find your C. After you find C, you write your equation back. Okay, so if you want to see an example, let's say I gave you, let's say we have this, okay, 4t squared plus 6, okay? Then you want to get V from A, so what you do? V is the integration of 4t squared plus 6 dt. Then you integrate this, you plus 1, so 4t cubed over 3 plus 6t plus C, right? Okay, you're going to get this. Now you need to find the C. So if the particle started from O, you just have to sub V0, T0, so everything becomes 0 and C will be 0. Alright, then you write back the equation here properly. 4t cubed over 3 plus 6t. C is 0. Okay, so this is your V. So from A you can get your V. Okay, by integration. Okay, so acceleration questions are very similar to what you have learned in displacement and in velocity topics. So you have to use the formulas that you have learned and then apply them and then solve questions. Okay, so now we have finished the topic, actually motion along a straight line. We have learned about displacement as. Okay, let me just give you a quick conclusion. Okay, we have learned about S, displacement, then we have learned about V, velocity, and then finally today we learn about acceleration, and they are all linked together, they are all interconnected, because from S you want to get V, you have to just differentiate, you can get it. From V you want to get A, you also differentiate the dV, dt. Okay, and now let's say from A you want to go back to V, you just integrate the A, and from V you want to go back to S, integrate the V. See? So it's one big happy family, and you can change from one to the other, vice versa. Okay, so sometimes in the question they give you S, you want to find A, all you need to do is ds dt and again. So second order differentiation, you can get your from S to A to S, A to V, V to S, anything. Okay, so please remember this, memorize this also, memorize this so that in your exams you will know how to change from one to the other and find answers, right? Okay, let's look at example 1. Okay, a particle moves with of a velocity of t square minus 3t minus 10. Okay, this is given. Find what? Find the acceleration. You want to find what is A. Okay, what is A when V is given as 8. Okay, you are given V is 8, so I'm going to use V is 8. And since we have V here, we just take this whole equation equals to 8. So t squared minus 3t minus 10 equals to 8. And you bring the 8 over here. So t squared minus 3t minus 18 equals to 0. Factorize this. 6 and 3 minus 6 plus 3. Okay. So t equals to 6 and negative 3. So of course cannot take the negative value for t. T cannot be negative. So we will choose t equals to 6. But it's not our final answer. The question says find acceleration. So find A. Alright, now we don't have A. Okay, the equation for A is not given. But from the V, can you get the A equation? How do you get A from V? Alright, you just have to differentiate. So A is equals to dV dt. Okay, differentiate this, you get 2t minus 3. This is your A already. See? You just differentiate the V and you got the A. Okay? dV over dt is A. Alright, so now you take the t equals to 6 and to find your A, sub the t equals to 6 inside here. So it's 2 times 6 minus 3, which is equals to 12 minus 3, 9. And the unit will be meters per second square. Okay, this is how you get your A. Alright, now we go to B. Find the acceleration again, find A, when it is instantaneously at rest. So this is the magic word. At rest, you remember what you must use? When it stops, what do you use? There's no velocity, V equals to 0. This is what you use. Okay, when a particle is at rest, meaning it's not moving, there's no velocity. So V is 0. Okay, so since we have the V here, we take this V equals to 0. Alright, V equals 0. So we take the equation t square minus 3t minus 10 equals to 0. Factorize this. So it's t minus 5 and t plus 2. Okay, so here you got t equals to 5 and negative 2. Negative t cancel because time cannot be negative. So we choose t is 5. Okay, but the question says what? Find A. Find A. So A is this. We use this A and you sub the t is 5. Sub t is 5 here. So we get 2 times 5 minus 3. So finally answer is 7 meters per second squared. This is your answer. Okay, it's quite simple, right? Okay. I'll give you another example. Example 2. Okay, one last example. The acceleration of a particle is given as this. Okay, we are given a is equal to 8 minus 2t. Given that the velocity when it passes through O is 6. Okay, you are given passes through O means when t is 0, you are given v is 6. Okay, this information you're going to use later. When t is passes through O means when no, it's not t is 0 actually. Okay, yeah. Alright, so passes through O means a starting point lah, okay? So find the maximum velocity of the particle. So our job is to find the velocity first, okay? Now in this question there's no v equation, so you need to find the v equation first. Since you're given a, from a you need to find v. How do we do that? Do we differentiate or integrate? From a to get v, we have to integrate. Yes. So we write down the v is equals to integrate a dt, right? So a is 8 minus 2t, put it here, 8 minus 2t dt. Alright, then you will get v equals to 8t minus t squared, right? 2t squared over 2, so the 2 will cancel out. And plus the c here. Okay, now how do we find the c? To find the c, we are going to put in this information that we know. T when v is 6, t is 0. So we sub t is 0, v 6. Okay, so 6 equals to 0, 0. Let me do this. Plus c. So you get your c is 6. Therefore, your v becomes, sub the c back in here. So you get 8t minus t squared plus 6. Okay, we got an equation for velocity already. Okay, from acceleration we got an equation for our velocity. Now you want to find maximum velocity. Alright, so what do you know at maximum velocity? We know that at maximum point, minimum point, alright, dv over dt is equals to a, which is equals to 0. So we can use this. At maximum point, we know that dv dt is 0 and dv dt is a. So we know that a is 0. So what do you do? You take the a, okay, 8 minus 2t, let it be 0. Okay, we know that at maximum point this is 0. Then from here you find t. T equals to 4, right? 4 seconds. Right. But now our aim is finding the maximum velocity. That's the final aim. So we've got t is 4 already. We have to sub into the v equation now. Okay, let me go here. Alright, here. So what is v maximum? Sub into the v equation. T is 4, sub in here and here. So we'll get 8 times 4 minus 4 squared plus 6. And you calculate the answer and it will give you the 22 meters per second. This is the maximum velocity of the particle. Okay, are you all alright? So this is another example of velocity, and here we stop. We end the chapter of chapter 9. Okay, so I hope everybody will be able to do questions, do practice, and wish you all the best. Okay, see you all. Bye.